In this video, we'll continue to multiply polynomials together, looking at a second special product and a special scenario, and that is when you square a binomial. To do that, let's remember one thing, and that is a binomial that is squared could be rewritten as that binomial multiplied by itself twice. So x plus 1 squared is the same thing as x plus 1 times x plus 1. So if we remember that simple rule, we can do examples 1, 2, 3, and 4 together. X plus 7 squared is the same thing as the binomial multiplied by itself twice, x plus 7 times x plus 7. That product would be x squared plus 7x plus 7x plus 49 when you use FOIL. And then you combine like terms to get x squared plus 14x plus 49. Let's do that 3 more times and be thinking about what you notice about all 3 of these answers. We begin by writing out n plus 8 twice, use FOIL to distribute properly, and then combine like terms in the end. We'll change different colors so it's a little easier to see. The product of y minus 9 squared is y squared minus 9y minus 9y plus 81. And you combine like terms to get y squared minus 18y plus 81. In the last example, 9x squared minus 30x minus 30x plus 100. So the final product is 9x squared minus 60x when you combine like terms, plus 100. So when we sit back and observe all 4 of these answers together, we can notice a couple things. First, we notice that our first term and our last term of each one of these trinomials is the square of our 2 terms in the binomial. X squared is x squared, and 7 squared is 49. And then you can see that same thing happening in all of the other 3 examples as well, where our first and last terms are the square of our 2 terms and the binomial. The important part to observe is what happens in our middle term for all 3 of these products. And what we can see is that the middle term is always our first term and our last term multiplied together and then doubled. We see 7x is doubled to give us 14x. 8n is doubled to give us 16n. And that happens with all 4 of these. So if this pattern exists, we can express a rule for this pattern. And that rule is, if you have a binomial squared, the first term in your product is your first term squared. The second term is twice your first and your second term multiplied together. And the third term of the trinomial, that's your product, is the last term squared. And this is also true when you're squaring a binomial that is a difference as well. So let's see if we can use this special product in this pattern to multiply a binomial squared. And what we get each time is what we call a perfect square trinomial. It's a trinomial that's the perfect square of the binomial that we just squared. So in x plus 5 times x plus 5, this is x plus 5 squared. Again, we could use FOIL to multiply this if we would like, or if we can learn this shortcut, this product rule, we can get straight to our answer. So we know that since this is a binomial squared, our outcome will be our first term squared. Our middle term is going to be our first and our second terms multiplied together. So x times 5 is 5x. and then you double that to get 10x. So we get 10x for our middle term, and then our last term is always our second term squared. So 5 squared is 25. If you're a little confused of how we got that answer, you could use FOIL to check that it works. Okay, and you'll see that that would be the same answer you'd get if you used FOIL. Let's do that product rule again. Here we have x minus 3 squared. Now we could write this out and use FOIL to do this, or we can remember our special product, which is our first term squared, since it's a binomial. Our middle term is our first and our third multiplied together, so negative 3x, and then you double that to get negative 6x. Then our last term is our negative 3 squared, which ends up being positive 9. Let's do this a few more times and increase the pace a bit. X minus 4 squared, we use our product rule. We square our first term, so x to the 6th, and then we multiply our first and our second term, so we get negative 4x to the third. When we double that, we get negative 8x to the third. And then our last term is always our second term squared, so we get plus 16. For number 4, we square our first term, 4x to the 8th. We multiply our first and second together and then double it. So that'll be 14x to the 4th doubled is plus 28x to the 4th. And then our third term in the trinomial is the 7 squared, which is plus 49. And our last two examples include fractions and decimals, but the same rules apply. Square our first term, x to the 4th, multiply our first and second, and then double it. So we get 1/2 x squared. When we double that, we end up with 1/2, and 1/2 is just 1. So we get plus 1 x squared when we double that. And then our last term is 1/2 squared, which is 1 over 4. In our last example, 6x squared is 36x squared. 6x times 0.9 is negative 5.4x. And when we double that, we get negative 10.8x. And then our last term is a positive. 0.9 squared would be 0.81. Now, finally, we just want to make sure that when we are using our special product rule, we are very careful about squaring binomials. A very common mistake when squaring binomials is that people have a tendency to try and distribute the exponent and get the answer of 16x to the 6th plus 25. This is a very common error that we sometimes get. And if we use this rule, we'll see why this is not quite correct. Because our special product rule says that the real outcome of this should be 16x to the 6th, and then you multiply the first and last together and then double it, so you should get plus 40x to the 3rd plus 25. When we simply distribute this 2 to the binomial, our outcome is missing the middle term. So make sure that when you're squaring binomials, you do not make this mistake.